Okay, we're in section 51 now. Again, my name is Ron Bannon. This is the draft version of Webster Wells' Advanced Course in Algebra, circa 1904. It's an old document. There's going to be contents, there'll be examples, and then exercises for you to work on. This document has been prepared for the Prison Mathematics Project. I will publish at a later date. If you want to reach out to me in the meantime, my name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right, let's take a look at the material. And again, I'm not going to read the content to you, but we'll certainly go through this. This is about the quadratic equation and the quadratic formula. All right, so we'll have a quadratic equation and we'll have a quadratic formula. And certainly it's something you want to pay attention to. All right, it's something that I don't want to use unless I have to. There'll be examples that you get to go through. Certainly we're suggesting you read this section over here and do the problems. All right, so oops, I got to erase this stuff. I guess I was talking to somebody else about this before. Let me erase it all. And I guess I got some other things to erase. So I'm going to erase this. We'll go through the problems. If there's anything else over here. No, I guess I just explained this to somebody else earlier. So the way I write a quadratic equation down is I try to write it down in a standard way that's used nowadays. It typically looks like this over here, and then there's a formula over here. All right, that's a quadratic formula. So to solve a quadratic equation, that's the ax squared plus bx plus c equals 0. Use this formula. Of course, Wells does all kinds of tricky things with it, but deriving that formula is not difficult, and certainly I think that's been done before. But if not, certainly I'll do it at a later time again as well. But it's easy to derive. All right. So what I want to do is when I'm doing the problems over here, my claim is I really don't want to use the quadratic formula. What I want to do is I want to see if I can factor the problem. Right now, I'll also use quadratic formula, but to factor this thing, what I do is put 2x and x. This equals 0. And then I'm looking at the 18, and I'm going to say 9 and 2. Let's see, I think that might do it. Let me see, I'm going to say plus 9 minus 2. Let's see if that works. You get 2x squared, and then 2x times minus 2 is minus 4, plus 9 is 5x, and 9 times minus 2 is minus 18. And then you take these factors, set them equal to 0, and that's really not so bad. For example, this factor over here becomes 0 when x equals minus 9 halves, and the other factor becomes 0 when x is equal to 2. These answers are listed for you, but I do want to go through the quadratic formula. If you're using the quadratic formula, you need to identify the a. In this particular problem, it's 2. The b. In this particular problem, it's 5. And the c. In this particular problem, it's minus 18. And what's going to be x equals, I'll be careful, it's going to be the opposite of b, which is going to be minus 5, plus or minus. Now this is always more difficult, but let's take a look at it. It's going to be the b squared. Again, if you can't remember the formula, it's written up there. And you should have the paper in front of you. B squared is 25 minus, well, 4ac. So I'm write this on the side. 4a, and c is minus 18, right? And what's that going to give you? Well, let's take a look at it. 8 times minus 18. Again, 8 times minus 18. That's going to be minus 80. And 8 times 8 is 64. That's going to be minus 144. Now, minus 144 is plus 144. I think I made a mistake somewhere. Now, I wonder what I did. I said b squared is 24. I must be daydreaming. It's 25, right? And what do you get bottom? Twice a, which is 4. Let's go through that. What do you get? You get x equals minus 5 plus or minus square root of 169 over 4. This gives you minus 5 plus or minus, the square root of 169 is 13 over 4. Well, it's a lot of work, isn't it? Again, I want to point out why I like factoring so much. It's so much easier. provided you can factor, by the way. There's two different answers over here. I'll write them down for you. X equals, well, minus 5 plus 13 is going to be 8/4. Or, now minus 5 minus 13 is minus 18/4. What do I give there? X equals 2, or, well, minus 18/4 minus 9/2. Are we getting the same answer? We're getting 2, and we're getting minus 9/2. That's good, all right? Let's look at the next one. The next one is not written in the form I like, so we have to write in the form we like. And what's that going to be? Well, 110x squared minus 21x plus 1 equals 0. Well, again, my claim over here, I'm still going to factor it. All right, so take a look at it. I'm going to say 11x and 10x. It should be easy to factor if it's doable. If it's not doable, it's not going to be easy to factor. I'm going to say 1, 1. When I say doable using integers, minus, minus. Let's see if that works. You get 110x squared. You get minus 11 minus 10, which is minus 21x. And you get plus 1. And the answers are very easy. What are the answers going to be? Let me write this down. X equals, well, that would be 1/11 or 1/10. Again, those answers are listed for me. Now what I'm going to do is use quadratic formula. As I do that, I'm going to write down the A, the B, and the C. The A is 110. Give me 1 second. The B is minus 21. And the C is 1. So I'll write it down. What's going to be X equals. And then one thing I love about quadratic form is it really requires, you have to do the arithmetic. And let's see, minus B, which is going to be 21. So notice an error here. I'll correct that error. This is an error. I need to correct it. All right, let's keep going. Now 21 plus, you're not going to see that error, by the way. The reason for that, the PDFs are going to be updated. Let's see. I got to do the B squared, right? So I know it's minus 21 squared, so I have to do 21 times 21. Well, let's see. You get 21, and then 2, 4. So you get 4, 4, 1. I'll write that down for you. Minus, well, now I got to do the 4 times the A, that's 110, times the C, which is 1. That's going to be 440. Over twice A. What's twice A? 220. This doesn't look too bad. It's 21 plus or minus. Well, 441 minus 440 is just 1, and the square root of 1 is 1 over 220. This is going to give you two different numbers. It's going to give me 22 over 220, and the other one is going to be or, well, let's see, that would be what? 21 minus 1 is 20 over 220. I need to reduce those. 22 over 220 is going to be 1/11, or 20 over 220 is going to be, I'm sorry, I made a mistake. I said something that's not true. So 22 goes into 22 once, and 22 goes into 220 10 times. Sorry about that. Now, when you get 20 over 220, 20 goes into 20 once. Let me erase this business over here. I don't need it anymore. That's just my scratch work. So 20 goes into 20 once, and it goes into 220 11 times. Are we getting the same answer? Of course we're getting the same answer. It would be outrageous otherwise. All right, this one over here, I'm gonna do it a little differently. The reason for that is I'm looking at it. I could write the A, B, and the C down, but I'm going to multiply both sides by minus 1. It makes it easier for me. What do you get? 5x squared minus 14x minus 3 equals 0. I'm going to make some attempt to factor it. What's nice about this factorization, it's easy. And 5x times x, 5x squared, I'm going to do 3. So I'm going to say 3 and 1 minus plus. Now, when I say something's easy, I'm going to still try it. So that's going to be 5x squared. That's good. Minus 15 plus 1 is minus 14 minus 3. And these answers are pretty easy to do. So I'll put the first one down. X equals, well, what are you going to get? You're going to get minus 1/5. That makes the first factor 0. Or x equals 3 makes the second factor equals 0. Okay, I'm going to use this one over here to write the A, B, and the C down now. What's the A? The A is 5. The B is minus 14. And the C is going to be minus 3. Let's write this down. X equals, be careful. Opposite of b, which is 14, plus or minus. All right, we got to do 14 squared, because minus 14 is something that's 14 squared. I'll write that down for you. Side arithmetic. Let me see. So I did 10 times 14, 140. And 4 times 14 is what? 40 and 16, 56, right? That's 196. This is one of the reasons I don't like quadratic formula. It's like I have to do this arithmetic. And then what? Minus 4 times the a times the c, which is minus 3. What would that give me? That would give me minus 60, right? Well, minus a minus 60 is going to be plus 60. All right? Again, I want to repeat to you how easy it was to factor. Now, factoring is not always easy. I'm just saying how easy this was to factor. What do you get on bottom twice a, which is 10? Let's see if we can do that. 14 plus or minus. And I lost track of what I was doing already, so it's going to be twice a is 10, right? Well, we get 196 plus 60 is going to be 256. Right? So, I guess I got to do more arithmetic here, right? So what do you do over here? 256. And let's see. I think I might have made a mistake somewhere. And let me take a look at this. And I must have made a mistake somewhere. 256. Let's see. I'm going to say 16. Maybe it's not a mistake. Maybe I'm just daydreaming or something. 16 squared, right? What's that going to give you? Well, it's 160. And 6 times 16 is going to be 60 and 36, 96. Yeah. So let me write that down. X equals 14 plus or minus 16 over 10. I'm not sure what happened. I have brain freeze, I guess. Let's take a look at that over here. What do you get? X equals... Well, let's see. 14 plus 16 is going to be 30 over 10. And the other one's going to be x equals, this is an or, we read it as plus or minus. That would be 14 minus 16, which is minus 2/10. Well, 30 over 10 is 3, and minus 2 divided by 10 is going to be minus 1/5. Are we getting the same answers? Of course we are. All right? Those answers are also listed over here. All right, number 4, I'll be honest with you, it looks like, and someone says, how could that be a quadratic equation? Well, what I'm going to do is multiply both sides by the LCD. All right, what's the LCD? It's going to be x minus 6, x minus 5. Let's do that. What are you going to get? 3 times x minus 5 minus 2, x minus 6. On the other side, you're going to get 1 times x minus 6, x minus 5. Yeah, it's going to be some work. What do you get over here? 3x minus 15 minus 2x plus 12. And then you can get x squared minus 11x plus 30. Yep, it's quadratic. Let's just simplify it. And what are you going to get here? 3x minus 2x is x, right? And minus 15 plus 12 is minus 3. X squared minus 11x plus 30. Again, I'm going to keep working through it. I want to get a 0. 0, x squared minus 12x. And then what are you going to get? Plus 33, right? All right, let's see if we can do it. I'm going to see if I can factor it. Now, certainly someone says, how do you know you can factor? You don't. You just simply try. And what's nice about this, if I'm using finger numbers, there's not many tries. So looking at it, I'm going to say it's either 33 and 1 or 3 and 11. And it appears that there's no way I'm going to get it, not using finger numbers. So I'm going to cross this out. It's not working out. The next thing I'd do is I'd probably either complete the square or use the quadratic formula. I'm going to complete the square for you, though. And let me go through that with you. So to complete the square, take away 33 from both sides. I'll write that down for you. X squared. I'll do it another way, too. Don't worry if you can't follow this. Half of minus 12 is going to be minus 6 squared plus 36. Add 36 to both sides. Well, 36 minus 33 is 3. And over here you get a perfect square, which would be x minus 6 squared. Then what I do, use square root rule. X minus 6 would equal plus or minus the square root of 3, or x would equal 6 plus or minus root 3. Put a circle around it, look at the answer key, and that's in the answer key. I also want to use quadratic formula. All right, so if I'm using a quadratic formula, I want to point out I'm using a quadratic formula in this thing over here. So the A is 1, the B is minus 12, and the C is 33. Now you would need to know the quadratic formula. Let me write that down for you. X is, let's see, opposite of B was 12, plus or minus, that's going to be tough. So B squared, that's 144. That's over here. I got to do 4AC, right? So 4 times 1, and C is 33. What would that give you? I'll give you 120, 132, right? Over twice A, which is 2. I got a lot of work to do, don't I? So it's going to be X equals, that's one reason I don't like the quadratic, it's just too much work. Let's see, 144 minus 132, that's going to be 12, right? Over 2, I got to keep going. 12, well, the square root of 12 contains a 4, so that's going to be 2 root 3s. Sorry about jamming that in there. Maybe I should clean that up because it doesn't look right. Write that down again. X equals 12 plus or minus, let me repeat that again. 12 contains a 4. The square root of 4 is 2. Root 3 over 2. Let's divide through. What do you get? 6 plus or minus root 3. Do we get the same result? Of course we do. It'd be outrageous to get otherwise. All right, so I'm going to look at this one over here. To be honest with you, it looks a little strange to me. And I'll tell you why. You may not know why it looks strange to me, but this guy factors to x minus 2, x plus 2. All right, but I got some strangeness going into this side, so I want to rewrite it. Right now, someone says I don't want to rewrite it, but I'm going to rewrite it. You may say I'm not going to rewrite it. That's fine. Let me rewrite this. Oops, let me get my pen out. So I'm going to write this as 1 over x plus 2. Well, the first term hasn't changed, but the next term I'm going to factor out a minus 1, and minus a minus would be plus. And what do you get over there? You would get x minus 2 equals x squared plus 3x minus 6 over x squared minus 4. I'm going to multiply by the LCD. Let me remind you the LCD of this problem, and I'm looking at this over here, is going to be x plus 2, x minus 2, or if you prefer, just write down x squared minus 4. Well, let's do it. What do you get for the first term? An x plus 2 would cancel off, so you get 1 times x minus 2. The next term, well, the x minus 2 would cancel off, and you're left with x plus 2. On the right side, the x squared minus 4 would cancel, and you're left off with x squared plus 3x minus 6. Let's keep going. This is x minus 2 plus x plus 2, and this is going to be x squared plus 3x minus 6. Let's keep moving. What do you get over here? 2x equals x squared plus 3x minus 6. You get 0. This would give you x squared. I'm subtracting 2x from both sides, by the way. Plus x minus 6. And what would I do? I would just factor it. And certainly I'm looking at it, and sometimes I'm confused, but I'm going to try. X and x, I'm going to say 3 and 2. And that would be plus 3 minus 2. That wasn't bad. You got that. So what do you get over here? X is 2, or x is minus 3. These answers are listed for you, but I also want to use quadratic formula on this one here. Right? I don't like the quadratic formula. So what I'm going to do over here, I'll write it down for you. A equals 1, B equals 1, and C equals actually minus 6. Let's write this down. X equals, let's see, the opposite of B, minus 1, plus or minus, that's a plus or minus. The B squared, which is 1, minus 4 times 1 times minus 6. So that would be 4 times 1 is 4, times minus 6 is minus 24, and minus 24 is plus 24. What goes on the bottom? Twice A, which is 2. Let me keep working on it. What do you get over here? X equals minus 1 plus or minus, well, 1 plus 24 is 25, and the square root of 25 is 5. Okay, we got two numbers. What do you get? Minus 1 plus 5, which is 4, over 2, or minus 1 minus 5, which is minus 6 over 2. What numbers do you get? X equals 2, or minus 3. We're getting those numbers clearly, all right? Now, certainly, someone said a lot of work to get that. Well, you decide, all right? I like to factor if I can. If I don't, if completing squares is easy, I like to do that. And if that's not easy, I go right to the quadratic formula. All right, this one's more difficult. I'll tell you the number one reason it's more difficult. I got these coefficients, all right? So I want to kind of write it in a standard way, and that's going to be AC, x squared. And let me just see if I can put this one down. I'm going to write down plus BC minus ADX, that's those two middle terms, and then minus BD, and that equals 0. Now, granted, someone's going to say, well, how are you going to do that? I'm not going to say you can't do this. I'm still going to try to factor. All right? I'm still going to try to factor. And yeah, certainly, that's too difficult. Maybe it is. Let's write this down. I'm going to write down AX. I'm not going to spend much time doing it, though. CX. And then in the end, I don't know. I'm going to write BD. Let's see. I'm going to say plus minus equals 0. I don't know if it works. Let's try to look. What would you get for first term? You get ACX squared. Worked beautifully. Then what do you get? You would get minus ADX plus BCX. That worked beautifully. And you get minus BD. So I'm ready to write my answer down now. What's my answer going to be? Well, X is going to be equal to, let's see, minus B over A, or X would be equal to D over C. All right? I still want to use a quadratic formula, though. I'm going to push this up, and I'm going to write it down now. The big A is AC. The big B is BC minus AD. Again, I don't like the quadratic formula. And the C is minus BD. All right? This is going to be tough. So what's X going to be equal to? X will be equal to the opposite of B. Well, the opposite of B is going to be AD minus BC. Let's see what we get next. Plus or minus. It's going to be tough. I'm going to do it on the side. I got to do B squared. I have to do it. So I have to do the B squared. What's that going to be? B squared C squared plus A squared D squared. Here comes the tough part. What I mean by that, we're doing BC minus AD, BC minus AD. It's going to be tough. I'm not saying it's going to be easy for you. So I hope you realize the B squared C squared came from and the A squared D squared come. But it's the middle term for a lot of students that are confusing. Let me write this down. So we get B squared C squared plus A squared D squared. It's the middle terms that kill people off. What are you going to get? Let's write this down in order. You're going to get A, B, C, D. That's this times this. And then you're going to do this times this. What would that give you? Minus A, B, C, D. So what do you get over there? Minus 2 A, B, C, D. All right, that's the B squared. All right, next thing I got to do, I got to do 4 A, C. That's the big C. Well, 4 times A, that's 4AC. You see it? Times a C, so I'm going to put a minus sign over here, and that would be BD. Well, I have the B squared minus this thing. And what would that give me? That's pretty simple. What are you going to get over there? Let's take a look at that. You're going to get B squared, C squared. Let's see, I guess you get 2 A, B, C, D. I'm combining the two terms in the middle. You know, I notice I wrote things out of order, so I'm just going to erase that and write the right order down for you. I didn't mean to confuse you with that. That would be A, B, C, D. Put it in proper order. Plus, let's see, A squared, B, I'm sorry, made another mistake. A squared, D squared. It's worked, though. I mean, this quadratic formula is really crazy. What goes on the bottom? Twice A. What's twice A? Oh, by the way, this is the answer for me factoring. What's twice A? That's 2AC, isn't it? All right. Someone says, am I done yet? I don't think so. Let's write this down. So X equals, and you get 2AC in the bottom. Let's see, AD minus BC plus or minus, that's going to be crazy. Well, not so. It's really a square. And what's that square going to be? Well, it's going to be, let's see, BC plus AD squared. It gets pretty tricky. Let's put this down now. What do you get? X equals, I'm running out of room. I got to push it. Get my eraser out. Let's write this down. And this gets crazy looking, doesn't it? Let's write this down now. It's actually crazier than it looks. This quadratic formula is a killer. 2AC, and then you get AD minus BC plus or minus, oops. Oh boy, that's going to be a tough one. What do you get over there? BC plus AD. Let's keep going. Wow. What do we get over there? Oh, by the way, there's a subtlety here that I've not discussed. Is the square root of a square. Should be the absolute value, but I got that plus or minus in front of it. That's taking care of that business. Okay, what do we get up here? Oh, boy. Let's do the plus first. That's what I'm doing now. So AD plus AD is 2AD. Now, minus BC plus BC is none. That's 2 AC. This is so much work, it's incredible. The 2's cancel, the A's cancel, you get D over C. Were we expecting that? You're not kidding, we were expecting that. Let's do the next one. Let's do the minus sign now. What are you going to get when you do the minus sign? It's going to be or. Let's see. I'm going to do the minus sign now. That's what I'm doing. So you can get AD minus AD, that's no ADs, minus BC is minus 2BC over 2AC. The 2's cancel, the C's cancel, and you're left with minus B over A. Were we expecting that? Yes, we were. All right, let's look at the answer key. Are we getting those answers? Whoops, I made a mistake on my key. Let's see where that mistake is. And I made a mistake in my key. Another mistake. I got to correct it. You're not going to see the mistake, though. This is a mistake. That 2 should be a C. And I make mistakes sometimes. There's no doubt about it. All right? So I'll have to correct that one, too. There's 2 errors I caught already. This is what I mean about working over someone's work. You're going to see errors. And, certainly with most modern publishers, when you reach out to them, it pretty much goes into a black hole, never to be seen. And the problem with it, there's such a long chain of people working on these massive textbooks that corrections really are hard to come by. But I'll be honest with you, if someone sends me a correction, it's going to be done immediately. And then the PDF will be posted, all right? So it hasn't been published yet, but it would be posted at some point. Now, I got to be honest with you, this one over here, it's really, they're problematic roots. So I'm going to look at it, and, the first thing I'm going to do is just get rid of that denominator. And the way I'm going to do it is just multiply both sides by the root of 5 minus x. And let me just do that initially. What are you going to get? Well, you're going to get the square root of, let's see, 5 plus x times 5 minus x. The next thing you're going to get plus, well, the root of 5 minus x times the root of 5 minus x is 5 minus x. Before I go forward, though, you may want to just think about what the possible numbers are. But right now, I'm not even thinking about it. But later on, you're going to talk about what the domain of the answers would be for this problem. But let's not worry so much about that. What are you going to get? The other thing, you can get 12. Now, there's one thing for sure I know, x can't be 5. If x is 5, it's out of the question. You may wonder why that is. I'd have a division by 0. All right, so that's one thing I know. Now, here's another problem I'm having. I'm looking at this guy over here, and I'm going to try to simplify it. And what would you get over here? You get 25 minus x squared. What do you get over here? Well, I'm going to get the radical isolated. And what do you take 5 from both sides, right? You would get 7 plus x. All right. What am I going to do now? I'm going to square both sides, and that also introduces errors. But let me see what happens when you square both sides. What do you get? 25 minus x squared. And when you square 7 plus x, you get 49 plus 14x plus x squared. Well, I got to get to 0. It's a quadratic. 2x squared. Let's see what else you get. Plus 14x. That's not so bad, right? And then what would you get? Let's see, 25 from 49 is going to be 24, right? I would divide both sides by 2. I would get x squared plus 7x plus 12. The next thing I would do is I try to factor it. X and x. Let's see, 3 and 4, right? X equals minus 3. Or x equals minus 4. Okay, I realize this is really difficult for some students, but I can't say enough times, I don't know if they're the right answers. So someone said, oh, just trust your answer key. Well, you shouldn't be trusting anyone at this point. You should be plugging the numbers in. So I'm going to plug them in, see if it's okay. All right, now where am I going to plug it in the original equation? And someone says, what's the original? It's what they gave me. So let's try the minus 3 first. I know it's tough, by the way. What are you going to get? Root 2, right? Plus root 8 equals 12. Well, it's going to be tough, isn't it? So I'm checking the minus 3, right? That's going to be root 8, right? Well, I'm going to multiply both sides by the root of 8. Right? I'm going to get rid of that fraction. What are you going to get? Root 16, root 64 equals 12. Root of 16 is 4, right? The square root of 64 is 8. That worked. So I know this is a good answer. Now let's try the minus 4. I'm going to try x equals minus 4. In the original statement, what are you going to get? The root of 1, the root of 9 equals 12 over the root of 9. 1 plus 3, 12 over 3. What's 12 over 3? 4. What's 1 plus 3 is 4. Both answers work beautifully. All right? And again, I know that's difficult to get through, but we're encouraging that you try. Let's look at this one over here. And again, it looks bizarre. I mean, you know, how do you do that? Well, we're going to recommend that you isolate a root. And so I'm going to isolate the root of x minus 1. And what do you get? You get 4 minus the root of 3x plus 3. I'm going to square it, both sides that is. You could introduce an extraneous solution here, but I'm not worried. This will be, whoops, I didn't mean to do that. When you square both sides, and it's going to be tough for you, you're going to get x minus 1 on the left side. On the right side, you're going to get 16 plus 3x plus 3. Oh, this is going to be tough, isn't it? So let's write this down. So it's 4 minus 3x plus 3 times 4 minus 3x plus 3. Well, the first and last terms are easy. It's 4 times 4 is 16, and the last term would be, you know, minus root 3 of the quantity 3x plus 3 times minus the root of the quantity 3x plus 3. That just gives you 3x plus 3. That's all it gives you. But now I got, you know, minus 4 of those radicals, minus 4, which is minus 8 of those radicals. This is a lot of work. All right, let's take a look and see if we can do it. This will be x minus 1. 16 plus 3 is 19, plus 3x, minus 8, 3x plus 3. I got to get the radical alone on one side. It's all over the place. So I'm going to say 8 root 3x plus 3 is equal to, well, complicated, right? 2x and plus 20. I'm going to divide both sides by 2, just to make the number smaller. And I'm going to square both sides again. Right? What do you get? 16 times 3x plus 3. If you square the right side, you get x squared plus 20x plus 100. It's nasty numbers. 6x times 3x is 48x. 48. This is x squared plus 20x plus 100. Got to keep working on it. What do you get over here? Well, you're going to get x squared minus 28x. Sorry about that. And then what do you get? Plus 52, right? All right, it looks tough. Not really. I think it's factorable. Let's put this down. 0, x and x. 52, I'm going to say 2 and 26. And I can say minus minus. All right. That works out pretty nicely. So looking at that, I'm not even thinking about the original equation. I'm going to say it looks like x is 2 or x is 26. Now, I don't know if I introduce an error by squaring. You can actually introduce errors quickly by squaring. So I need to check them. And let's put 2 down first. I think it's easy. And again, I'm checking in the original. I don't know if it's true. What do you get over there? 2 minus 1 is 1. The root of 1 is 1. Let's see. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3. Well, that worked beautifully because 1 plus 3 does equal 4. Let's see if this one works. And I'm not saying it does. All right? What do you get over there? The root of 25 is 5 plus, let's see, what would you get? 3 times 26 is, that's going to be a tough one, right? 3 times 26 is 60, and 18, 78, and 3 is 81. And the root of 81 is 9. That doesn't equal 4. Now, their difference is 4. That's where it came about, by the way. But this is a bad answer. It's extraneous. All right, extraneous. What I mean by that, if you took this equation, wrote this down instead, took 9 from both sides, and here, if you square both of these sides, it's a true statement. That's where that squaring comes into play. We did something really bad. We just didn't know we were doing that. That's a bad answer over there, all right? There's only one answer to this. What's the answer? X equals 2. Put a box in that. Again, if you look at the key, they'll say that only x equals 2 is the solution of it, all right? Okay, that's a lot of problems. I know that. So, my whole take in that was, basically I like to factor, use zero product rule. Completing square is not bad if I can see it. And the quadratic formula, sometimes I have to do it. All right, I have to do it sometimes. So you do the exercises on your own. It's a lot of work. Get through it. And there's problems over here. Just make sure you can do it. All right, I really mean that. Make sure you can do that. They're not bad. They start out pretty easy. They do get more difficult. You work through that material on your own. All right? So I'm going to say work through that. There's a lot of problems there. And the problems toward the end do get more difficult. I assure you, you can do those problems if you're willing to give it a try. All right, it does take time and effort, though. I put some work down there for you. Not all the work, but enough work for you to get move forward. I certainly have answers for all the questions, by the way. All right, so work through them. See if you can do it. Or if you get stuck, that's fine. Try again. Come back to it. Keep hacking at it. You'll eventually get there. It does take a lot of time and effort. Wow, there's a lot of questions, aren't there? 37, 38. Again, the more time and effort you put into this, the easier your understanding future math courses will become. So let's keep looking. It just doesn't seem to stop, does it? We're up to 51, 53, 54. Will they ever stop? If they don't stop, we're in hell. I bet it's going to stop soon. That's a lot of questions, isn't it? You try your best, though. Wow, we're at 70 already. This is crazy. When's it going to stop? Let's see if we get to 80. Wow, we got to what? 77 problems. You decide how much time and effort you're going to put to it. Don't let people push you around. All right, what do we got over here? We're at that Sage business. Sage code. All right, what's Sage? Sage is a computer algebra system. We abbreviate that CAS, C-A-S. It's free. Go to this website. If you have the PDF electronic form, just click on that, bring you right there. You either download the application or use the interactive web-based application. Right, now again, if you want to go back and look at the original videos we started off with, it would be 00 WW Sage, and you would see me go through how to run Sage on online and on a computer. But the bottom line is, you decide, all right, what you're going to be doing. But they're really nice software. It actually does a lot of nice things, and this is just introducing it. Again, if you need to reach out to me, my name is Bannon. My email address is B as in boy, @NNON.US. All right? Okay, let me repeat this. If you see an error, please reach out to me and let me know there's an error. I'll give you credit if you want credit. If you say, please do not put my name down, I won't put your name down. All right? But if you don't say that, I'm going to put your name in the document. All right? So please try to contribute. You'll be contributing not only to making this a better document, but you'll be contributing to other people looking at the document. I mean, they'll benefit from it, and I hope this document lasts a very long time. And it's well over 100 years now. All right, it's certainly surviving. People still talk about this guy's work today. It's incredible. All right. Now, I'm not saying it's like an Euler or a Gauss or something, but he really did write some really good algebra books. All right. Okay. Thanks for paying attention.